All right. Okay, so comparing quantities. All right, let's make sure we're following along, you guys. Okay, so you guys have printed on your page 5 dimes and one, I'm sorry, those are nickels and quarters, not dimes and nickels. 5 nickels and 1 quarter. There are some different things that if we wanted to, we could compare about this thing. We could compare the number of coins, right? That'd be a pretty easy comparison. We could also compare the number of cents that each coin represents. Okay, let's cancel. Oh, yay, I got it back. Okay. We could also compare the number of cents that coin represents. Let's start with the number of coins. If we compare the number of nickels to the number of quarters, what would we get, folks? Okay, what is it? 5 to 1. Let's go ahead and write that in. See if I have a 5 to 1. Okay, how about the next one? It says we can compare the value of the quarters to the, the value of the nickels to the value of the quarters. What do we get if we do that? Cameron? We get 1 to 1 because the nickels are worth 25 cents. The quarters are worth 25 cents. And if we simplify that, we get 1 to 1. We could compare the mass of the nickels to the mass of the quarter. What would we get then? Mira?
I can give you the answer if you give me a balance.
Oh,
5 quarters and 5 nickels and a quarter.
Good answer. I like that. I was prepared for somebody to try to give me an answer, and I was going to say you don't know, but that was a perfect answer. Good job. All right. Yeah. So there are when we're talking about ratios, are we talking about numbers?
No.
No, we're talking about what? A comparison, but there are lots of comparisons that we can make. And yes, ratios are made of numbers, but they are not giving us quantities. They are showing a comparison between different things. All right. So in the first example, we are comparing the number of nickels to the number of quarters, and we got 5 to 1. That ratio tells me how many times as many nickels there are as quarters. We're going to represent that with a bar model as well. So go ahead and do this with me, guys. How many units should I give the nickels? Rajveer? Yep. Here's a reminder how to draw uneven. When you guys have an uneven number for a bar model, split it slightly over half on the left and then divide that into, for 5, we would divide that into 3 and then divide the other uneven half into 2. How many units should I give quarters? Jude is not in here, but his little brother is. Owen. That's like the 6th time I've done that this year. Okay. Feel like I'm going to have to make a reparation for them. Okay, we're going to give the quarter 1 unit. All right. So friends, would this bar model change if I had, say, 10 nickels and 2 quarters?
Yes.
It would?
Yeah.
Right, it wouldn't, because no, what the bar model is representing is the number of units of nickels and the number of units of quarters. As it happens, each unit right now is only made up of 1 coin, right? So, but Declan, if I had, let's say if I had 10 nickels, I'm just going to draw dots in my units to represent how many things each unit would represent. And I had 2 quarters, that would be the same ratio, wouldn't it? It would still be 5 to 1. You say no? Uh-huh. No, I wouldn't actually, because what we're representing with the bar model is each section equals 1 unit, not 1 item. And when we write a ratio, these different parts of the ratios represent how many units I have, not how many items.
I'm so confused.
Okay, that's all right. Remember when we did the like on day 1 on Friday, we had pictures of boys and we had pictures of girls, and there were like 4 girls and there were 2, or was it like 4 and 8? I can't remember. Maybe it was 4 and 2. It was 4 and 2, right? And we do circles around 2 kids each. And that was to show that each unit represented a quantity of 2 kids. And so that's what we're representing. When we represent with a bar model, we're representing units. There could be 2 items in the unit. There could be 3 items in the unit. If I have 15 nickels and 3 quarters, does that change the ratio?
No.
Okay, if I have 20 nickels and 4 quarters, does that change the ratio?
No.
No, it doesn't. So that's why we're kind of running through this, is because it's really important to remember that when we're talking about ratios, we are talking about the comparison between number of units. We're not talking about the number of items. We can use those comparisons to solve problems where we want to find the number of items, but that's not what we're talking about. Okay, in the second example, we compared the value of the nickels to the value of the quarter, all right? And Cameron gave us that comparison. What was that comparison again, Cameron? Good. So if we were to, whoops, I drew that in the wrong place. If we were to draw a bar model representing this ratio, how would I draw a bar model representing a 1-to-1 ratio? Mira?
Maybe you could, make 2 bars the same length.
Yeah.
One of them you would split into 5, the middle one, and on the other one, you could just leave it.
No, I wouldn't do that actually, because that would represent 5-to-1.
Oh.
This is what I'm doing. 1-to-1 just means their units are the same. It's 1 unit for nickels, 1 unit for quarters. Would this ratio change if I had 50 cents worth of nickels and 2 quarters? Would it be the same? Eyes up here, please. Make sure you guys are engaged. Thank you. What about if I had 3 quarters? Well, now I'm struggling. And 15 nickels. Would the ratio be different? If I'm talking about the value of nickels to the value of the quarters? Yeah, say it with confidence. What do you guys think? No, that's the same ratio because I would have 75 cents worth of both, right? Good. Okay, so on the bottom of there, you can change. Did you guys, oh, you guys don't have that. I guess I took those notes off, so never mind. Your notes are slightly different than mine. Okay. So is the ratio of the number of nickels to the number of quarters different than the ratio of the value of the nickels to the value of the quarters? Yes. So fill in different on that line. Yes, it is most definitely different, isn't it? Okay, good. So what I want you to understand is that when we compare different attributes of items, we end up with different ratios because we're comparing different things. So super, super important. Okay, so you guys are going to have to keep straight, like, what am I comparing in this word problem, or what am I trying to compare in terms of like items? It's not always going to be like just physical items, right? In that last example, we compared the physical coins, but then we also compared the value, and they were different ratios. Okay, so on your Toyos, oh, this is a note I wanted to give you guys. I told the ELO group, but we don't include units with ratios. So when you have a ratio like say 1:2, 1-to-2, we are not including units with those. So don't include units in your work. These are, again, these are not quantities or items. These are comparisons. So all we're doing is showing the comparison. So yay, you don't have to include a unit. No, we are going to do a lot of unitary method. What I'm saying is that like when we did the value of the nickels to the value of the quarters and it was 1-to-1, we wouldn't say 1 cent to 1 cent. We wouldn't do that. Yeah. Don't give it labels. Thank you. Did I? Yeah, maybe I was unclear. Well, units is this. Yeah. Okay, maybe I'll change that wording because it is a little confusing with unitary method, but that's a different thing. All right, so in your textbook, we're going to work through numbers 1-4. I don't believe you actually need your textbook for these. They are reprinted in your notes for you. Let's do the first one together so we all know what we're doing. It says string A is 12 centimeters long. String B is 2 centimeters long. String A is 6 times as long as string B. So notice I have 6 units that represent string A. How many centimeters is each unit comprised of? Can you guys tell by looking at the bar model? Morgan? No, that's my entire length of my ribbon. I'm asking how many centimeters is each unit comprised of right now? Rajveer? 2 centimeters, good. Yeah, I just wanted to make sure we all understood that. All right, the ratio of the length of string A to the length of string B is what? Lucy? 6:1, good. Now, string A is what the length, I'm sorry, string B is what the length of string A? Dorothy? It is 1/6. That's how we want to write that, yes. How about the next question? The ratio of the length of string B to the length of string A. What is that? What is the ratio of the length of string B to the length of string A? Cameron? 1:6 is correct. Good job. Do you guys want to go through another one, or do you want to do numbers 2, 3, and 4 on your own? All right, go for it. Okay, number 2, Kira is 4 feet tall. Her younger brother, Ben, is 3 feet tall. Ben's height is blank, Kira's height. What should I fill in there? Ashlyn G? Yes, that's correct. Nice job. 3/4 times Kira's height. The ratio of Ben's height to Kira's height is what? Macy? Good. Kira's height is blank times Ben's height. Dorothy? It's not 1/4. Kira has 4 units and Ben has 3 units. So if I'm comparing Kira's height to Ben's height, remember Kira's going to be taller, right? So how many units would she have? Yep, 4. And how many units does Ben have, Dorothy? 3. Good. So 4/3, which if we simplify, what would that equal? 1 1/3. Good. The ratio of Kira's height to Ben's height, Mendel? 4:3 is correct. Nice job. Are we having, class, how many of us are having trouble with these kinds of questions? Like when we need to phrase it as a fraction? Okay. But remember, when you're having trouble, just remember what some of those hints that I've given you guys. Whatever we're comparing to, that is our denominator. Our denominator is always our standard of comparison. So if I'm comparing Kiara's height to Ben's height needs to go on the bottom, right? That would be our denominator. Okay, I'll give you guys like one of these. I don't remember what day it is, but I have some word ratios for you guys to write down to, or some word fractions that can help. All right, bag X is 15 kilograms, bag Y is 45. Bag Y is 3 times as heavy as bag X. The ratio of the weight of bag X to bag Y. Shafiq? That is correct. Nice job. Bag X is what times the weight of bag Y? Lucian? Good. 1/3. The ratio of the weight of bag Y to the weight of bag X is what, Declan?
3 to 1.
Good. 3:1 is correct. Way to go. Okay, next one. We're all caught up on notes, folks? Great. Okay. A pair of pants costs $27. A jacket costs $45. The ratio of the cost of the pants to the cost of the jacket. Michael? Good job. You could have started off with 27 to 45. That would be fine. But then you need to simplify it to 3 to 5. That's correct. Good job. The ratio of the cost of the jacket to the cost of the pants. Mira? Good. All right. Nice job. Morgan? Yes, I would like you to always simplify, and that's included. Yeah, so go ahead and change it. Ashlyn, do you have a question? All right, let's get back to notes. Okay, you have rod A is 27 centimeters long. Rod B is 1 meter long. So notice here I've got centimeters and meters. Oh, I have to convert one to the other, don't I? Right? It's always going to be better to convert the larger unit to the smaller unit. So how many centimeters is 1 meter, folks? Kylie? Yeah, so that's 100 centimeters. Okay, so If I were to set this up in a bar model, let's just change the units to measure rod B to match that of rod A before I compare the rods. We have this divided up into 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each unit represents 10 centimeters, right, guys? Okay. So that way my 20 centimeter bar is made up of 2 units, and my 1 meter bar, or my 100 centimeters, is made up of 10 units. So what's the ratio of rod B to rod A? The ratio of the length of rod B to rod A. Let's see, Cole, can you tell me that one? You put what? 100 to 20? Oh, 1 to 20? So on this one, remember, we can't say 1 to 20 because clearly rod B is bigger, right? That's because it's 100 centimeters. We could start off with 100 to 20, sure. And then we'd want to simplify it. So what would we simplify it to? Ashlyn G? 5 to 1, exactly. 5 to 1. Okay, so Ashlyn A, the ratio of the length of rod A to rod B. 1 to 5. Good job. So when we look at this, you guys, what we're doing is we changed the units so that each unit is comprised of 10 centimeters. Okay, let's take a look at this exit ticket together. It says change the unit so that the volume of water in both containers is measured in the same unit, milliliters, before doing any comparisons. This is number 6 on page 99. I think you're going to have to turn there. So you guys should know that 1 liter equals, anybody remember from science? How many milliliters does 1 liter equal? Uzziah?
Is it 1,000?
Yeah, 1,000 milliliters. Great job. Okay, go ahead and change and turn to page 99 and work through number 6. Okay, so you've got container E with 1,000 milliliters, and container F with 250 milliliters. Container E has 4 times the amount of water as container F. And the ratio of the amount of water in container E to the amount of water in container F. What's the answer to that? Uzziah.
1 to 4.
Let's see. Actually, let's take another look. Do you have your container E? Look at your picture. Does that one have more or less? Yeah, so should it be 1 to 4?
Okay.
4 to 1, good job. Okay, container F has what the amount of water as container E? When we're comparing it to container E, as what? Kylie R? Yes, good job. It has 1/4 the amount of water. The ratio of the amount of water in container F to the amount of water in container E. Macy? 1 to 4 is correct. Good job. So it's really key if you guys are comparing, can we compare different units in a ratio? Like, can we compare milliliters to liters? We have to convert, we would have to, if you have other problems like this in your homework, you're gonna have to convert a larger unit to the smaller unit. You would want to convert you'd want to convert liters to milliliters. You'd want to convert meters to centimeters. You'd want to convert pounds to ounces, and so on. We can compare different things. That's called a rate. That's going to be our next unit. But right now we're not. Okay.